Hello friends and my dear students, I welcome you all to my channel. This video is about 10 good problems on the chapter of rational numbers of class 8. This is the set number 1. So this video is part of the new playlist Maths 8 HOT. HOT stands for High Order Thinking, where I come up with 10 good problems that require high order thinking from each chapter, and so that you have a good practice of your of the problems on all the chapters, and you can evaluate your understanding and the concept clarity of concept by giving this by solving these 10 problems in approximately 30 to 40 minutes. So these are a set of 10 problems. So ideally you should be able to solve each question in 3 to 4 minutes. Please, it will be very useful for you to solve these 10 good problems that I will come up as different sets from each chapter. Now I intend to keep on making 10 good problems. That is, this series of videos will be unlimited. Let's see how it goes. So this video is part of my playlist Maths 8 HOT. HOT stands for High Order Thinking. And if you are new to my channel, or if you are not yet subscribed, or if you are visiting my channel for the first time, or seeing this video for the first time, and if this video seems to be useful to you, beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. And also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have the set of 10 problems paper on the left hand side, and on the right hand side I will solve them. Now, to be very honest and frank, I don't know, I'm not sure whether I will be able to solve all the problems. I will try my best, but there is a high possibility that I won't be able to solve I won't be able to solve any problem because of lack of concept or clarity or whatever, or maybe I will not understand the problem. So these problems are taken from various sources, some standard sources. It is not a problem from the textbook of author R.S. Agarwal, which I follow for making all the videos on my playlist CBSE Maths 7 and 8, following the textbook of author R.S. Agarwal. So if you have not watched those playlists, and if you are in class 7 or 8, and if you need a good understanding of mathematics from starting to end, I follow the textbook of author R.S. Agarwal. You can watch out those playlists, Maths 7 and 8. Maths 7, there are two separate playlists for class 7 and 8. Maths 7, CBSE Maths 7 R.S. Agarwal, and CBSE Maths 8 R.S. Agarwal. Okay, so let's start solving the problems. Let me quickly check if everything is visible or not. Okay. Now, it is highly recommended that you first try to solve these problems yourself, and if you are stuck at any problem, if you cannot solve it after multiple attempts, then only you see my solution video. Okay. The first problem, and also it is recommended that you have completed the chapter and you have solved quite a bit of problems from the relevant chapter before attempting to solve these problems, because these are a little bit of high order thinking problem. It will require good clarity of the concepts. Okay, the first problem says x, y, z are positive rational numbers such that y equals to z plus x. X, y, z are positive rational numbers. Okay, so we can say it is given that all x, y, z are greater than 0. Okay, and it is given that y is equal to z plus x. Okay, then the position of y on the number line is, first choice is to the right of x and z, to the left of 0, between 0 and x, none of these. Okay, sometimes it is easy to eliminate a choice. Some choice will be given, you can see the choice and clearly say that it is not a correct choice. So by elimination also you can arrive to the correct choice. Now between the choice C, it is saying that y lies between 0 and x. So let's see what is choice C saying. C is saying that y is greater than 0 but less than x. This is false. Why? Because as y is equal to z plus x, this is greater than uh, and and z plus x. Now okay, let's try to understand this, why this is false, a little step by step. It is given that x, it is saying that the choice is y less than x. Now it is given that x greater than 0 and y and z is greater than 0. This will imply that x plus z will be greater than z. We can say why? Because the reason is x is greater than 0. If you are adding some positive number to z, that number has to be greater than z. So we are having x plus z greater than z. Greater than. I can also say greater than z, or I can also say is greater than x. Since z and x both are positive, x plus z will be greater than x and greater than z. This will be since z is greater than 0. Now this implies, what is x plus z? X plus z is given as y. This implies y is greater than x. So choice C, it is saying that y lies between 0 and x, which means y is less than x. But it is false, as we have just proved that y is greater than x. So choice C is wrong. Okay. Now to the left of choice B, choice B is saying y less than 0. This is also not correct, because as y is equal to, we know, z plus x, and this is obviously greater than 0 plus 0, that is y is greater than 0. Why z plus x is greater than 0? Because x is greater than 0 and also z is greater than 0. Therefore we can say x plus z is greater than 0. The concept is, if you have that a is greater than, for any numbers a, b and c, if you have a greater than b and if you have c greater than d, for any numbers a, b, c, d, if you have this inequality a greater than b, c greater than d, then obviously we can say that a plus c will be greater than b plus d. So this is the concept that I have applied, that from the fact that x greater than 0 and z greater than 0, I can say x plus z greater than 0 plus 0. That is, x plus z is greater than 0 and x plus z is y. So y is greater than 0. So this means y has to lie to the right hand side of 0 on the number line. So B is false. A is false, B is false. Now none of this. D, we cannot yet decide about D until we see what is A. So what is A saying? What is A saying? To the right of x and z. To the right of x and z, meaning it is saying that y will be greater than x and y greater than z. Let us see whether this is true or not. So we have y equals to x plus z. Now this implies that y will be greater than x plus y will be greater than x. Now x plus z, y will be greater than, y is x, y is equal to x plus z, and we know that x plus z is greater than x because z is positive. If we add a positive number to x, whatever x is, if we add a positive number to x, that number, that is x plus that positive number, will always be greater than x. And x plus z will also be greater than z. Why? Because x is greater than 0. So we are getting x plus z is greater than x and x plus z is greater than z. This implies, since we know that x plus z is nothing but y, so we can say that y is greater than x and y is greater than x and y is greater than z. So choice A is correct. Choice A is correct. Hence, the answer is correct choice is A. Y lies to the right of x and z. Okay. So while I am solving the problem, you can pause the video and take a screenshot. I will pause for a few seconds after solving a problem so that you can take a screenshot. Okay, let's do problem number 2. Problem number 2 says that if x need to be multiplied with an expression is given to give product as a multiplicative identity, then x is. If x need to be multiplied with this expression to give product as a multiplicative identity, okay, so it is saying that if we multiply x with the given expression, that is minus 8 by 15 plus half, the product will be equal to multiplicative identity. We know that multiplicative identity is 1. From the properties of a rational number, we know that multiplicative identity, two important concepts, multiplicative identity is 1 and why? Because if you multiply 1 with any rational number, the result is that rational number only. So this is the equation we arrive from the given problem statement, and we have to solve x. Now, so what will be x? This implies that we know that this is a concept. You must remember that any rational number, let's say the rational number is x, any non-zero rational number, for any non-zero rational number x, if you multiply x with its multiplicative identity, a multiplicative identity of a rational number x is denoted by a power minus 1, or it is equal to 1 by x. For any non-zero rational number, the product of the rational number and its multiplicative inverse is always 1. We know from always 1. Meaning this is nothing but, we know that x multiplied by 1 by x is equal to 1, we know. So if it is, and from the given equation we can see that x multiplied by something is giving equals to 1. So this will imply that whatever this is, this will imply that x this will imply that x will be equal to this will imply that, let's say I am denoting this as y. I am assuming that minus 8 by 15 plus half is equal to, I am assuming it is y. So this is what is given, x multiplied by y is equal to 1 is given. So clearly now we can say that y is equal to the multiplicative inverse of x. Multiplicative y will be equal to multiplicative inverse of x. This is equal to x, by notation the multiplicative inverse of x is x to the power minus 1, x to the power minus 1. Okay. So y is equal to this. This will imply, or we can say that we can also say that x will be equal to multiplicative inverse of y. What is the concept? If you have two rational numbers x and y, specifically they are non-zero rational numbers x and y. If you have x multiplied by y is equal to 1, if the product of two non-zero rational numbers is 1, it means that the two rational numbers x and y are multiplicative inverse to each other. This means that x is equal to multiplicative inverse of y, that is y to the power minus 1, and y is also equal to the multiplicative inverse of x, that is x to the power minus 1. So using this concept, we can say that x is equal to multiplicative inverse of y, that is y minus 1. So hence, what is y? We have y is nothing but minus 8 by 15 plus half to the power minus 1. To the power minus 1 means multiplicative inverse or reciprocal. Now we have to simplify what is minus 8 by 15 and half. We have to do this simplification. Now we know if we do the simplification, we will get the LCM will be LCM. We have to find the LCM of 15 and 2, which is equal to 30. So this will be minus 16 by 30 plus 15 by 30, and we have the power minus 1. So this is equal to minus 16 plus 15 divided by 30 raised to the power minus 1. This is equal to minus 1 30 by 30 raised to the power minus 1. Now what is the multiplicative inverse of x? It is nothing but 1 by x. And what is the multiplicative inverse of a rational number of the form x by y minus the multiplicative inverse of x by y is nothing but we interchange the numerator and the denominator. This becomes y by x. So this will become 30 by minus 1. This is equal to minus 30. Okay. So what are the choices? Multiplicative inverse of minus 1 by 30. Okay. So this is what we arrived at. We have found x to be the multiplicative inverse of minus 1 by 30. So minus 1 by 30 to the power minus 1 means multiplicative inverse. So definitely choice A is the correct choice. So the choice A happens to be the correct choice. So we need not check the rest of the choices. Okay, no, sorry. Choice D is all of these. We have to check B and C. Additive inverse of, we cannot as of yet say that answer is choice A. We have to also see whether, so we can see that choice A is a correct choice. Okay. What about B? What about B? What is B saying? Additive inverse of 6, additive inverse, I mean short writing addi, which means additive inverse of 6 multiplied by 50. Let me quickly check if everything is visible. Okay. Okay. So additive inverse of 6 multiplied by 50, that is additive inverse of 30. This is equal to additive inverse of 30 means what is additive inverse of a number x, any number x? It is you just negate the number minus 30. So additive inverse of 30. So definitely minus 30. Okay. Now what is this number actually? So we have seen that the x will be actually minus 1 by 30 to the power minus 1. That is multiplicative inverse of minus 1 by 30, which is equal to minus 30. So we can see that B is also a correct choice. Okay. Let's see what is C. What is C? Negative of reciprocal of 1 by 30. Okay. So what is reciprocal of 1 by 30? reciprocal of 1 by 30 is equal to 1 by 30 to the power minus 1. Reciprocal of 1 by 30 is 1 by 30 to the power minus 1. You can also write it as 30. You can also write it as 30. Okay. Now, negative of reciprocal of 1 by 30. So, we have found reciprocal of 1 by 30 is 30. So, now negative of this implies negative of reciprocal of 1 by 30 will be hence equal to reciprocal of 1 by 30 is 30. So, its negative will be minus 30, and we can clearly see this is also correct. This is also correct because as per our result, we have already found that x to be equal to minus 30. So, we can see that all A, B, C are correct. So, definitely the correct choice will be choice D. So, whenever you have these kind of choices where the last one is all of these, always look out whether all the other choices are correct or not. Okay, let's solve question number 3. Question number 3. Okay, let's okay. So I'm pausing for a few. You can take screenshot of the solution of problem number 2. And this paper, the set of problems, or the set of 10 problems, the PDF, I will provide as a link in the description below. Okay, let's solve problem number 3. Now, it is not the case that my solution is the only way of solving this problem. In mathematics, there could be multiple ways of solving a given problem. So, if you have a better way of solving it, then it is fine, you go with it. But I am just providing you a set of good problems so that you can have a good practice, and your concept of the relevant chapter will be fine-tuned so that you can tackle good problems in your exam or any other competitive examinations. That is my primary intention. I am not trying to say that my solution is the only solution. No, definitely not. My solution could be very, very sloppy. As myself being a very, very average student, you will see that my solutions are never really, really that smart or very intelligent. I always try to think from the basics and try to use the fundamental concepts and use my limited thinking capability to solve the problems. So it is quite possible that I won't be able to solve any problem. Okay, so problem number 3. If x by y equals to minus 3, then the value of some expression is given. Okay, now it is given that x by y is equal to minus 3. Okay, and we have to find the value of this expression, minus x by minus y multiplied by x by y plus y by x. Now, the immediate question that comes in my mind is that it is given that x by y, and I can also see the given expression is also in terms of x by y. The first term is x by minus y, but I can always make the minus y as a y and make the x as minus x. That is, it will be minus x by y. So, and also in the second in the second term of the product, I see it is x by y plus y by x. Now, y by x is the reciprocal of x by y. Now my next thought process is, should I directly now substitute the value of x by y and simplify it, or will I try to simplify the given expression in terms of x and y, and see whether I can simplify it to a very, very simple or much simpler expression, and then finally I will substitute the value of x by y. Now let's try to do both way. I'm trying to simplify the given expression and convert it to a simpler form in terms of x and y. So if I just apply the distributive law of multiplication over addition, I can see this will be x by minus y. Now let's directly in the x by minus y term, let's make the y positive and make the so that it will be minus x by y. So I have minus x by y multiplied by x by y plus I have minus x by y multiplied by y by x. Okay, so I just simply applied the distributive law of multiplication over addition of rational numbers. Now what is this? The first expression, it's a product of minus x by y multiplied by x by y. Now I can always write it as minus of x by y multiplied by x by y. I can do this because minus x by y, I mean minus x by y, I can always express it as minus 1 multiplied by x by y. I can do this. Okay, I have this, and plus on the right hand side I can see that y gets cancelled, x gets cancelled, and I am getting minus 1. Okay, now what is this? Now this is turning out to be x square by y square, and this is I am having plus minus 1. Let it be. Now what is this? This is x by y whole square, and I have plus minus 1. Now I can directly substitute the value of given x by y. X by y is minus 3. So minus 3 whole square plus I have minus 1. Now minus 3 whole square, we know that the concept that minus x is any, if x is any non-zero rational number, then minus x to the power m will be equal to x to the power m if m is even. Irrespective of whether m is positive or negative, it has to be even. Like m could be m could be 2, 4, 6, 8, or it could be like minus 2, minus 4, minus 6, minus 8. Positive even, or it could be negative even numbers. Then we can say that minus x whole to the power m, where m is a even integer, is equal to x to the power m. So we can see minus 3, the power is 2, which is an even number. So we can write it as, the minus will be gone, so we have negative of 3 square, and we have plus minus 1. So this is equal to minus 9 minus 1. This is equal to minus 10. So clearly the answer is choice D. So this was the method that where I tried to simplify the given expression further in terms of x and y, and then finally I have substituted the value of given value of x by y. Now if the other choice would have been, if you would have directly substituted the value of x by y in the given expression, and then from there if you simplify it, I think both the methods will take the same time. So you can apply either method, any of the methods. Both are fine, I think. Okay, so you can take a screenshot of the solution. Okay, let's do problem number 4. The number of rational numbers with denominator as unity between minus 74 by 19, minus 74 by 19 and 103 by 21. It is asking the number of rational numbers with denominator as unity. Now what is the rational number with denominator as unity? It is like any rational number is of the form p by q, where p and q are integers and q is not equal to 0. So, and what are the rational numbers where q is 1? It is saying the denominator is 1. So q is 1 is nothing but any integers. So a rational numbers with denominator means simply it is an integer. Okay. So now we have to find that how many integers. So the problem boils down to the fact that how many integers are there between minus 74 by 19 and 103 by 21. How many integers are there? Okay. Now definitely minus 74 by 19 lies to the left of the origin on the number line, and 103 by 21 lies to the right of the origin on the number line. Now also we see that both the numbers are improper fraction. Both the numbers are improper fraction, irrespective of, by improper fraction I means irrespective of the sign. If you ignore the sign, the numerator is greater than the denominator. So this, if you write it in the mixed form, now the number of rational numbers between, okay. If I express these two given numbers in the mixed form, I get minus 74 by 19 will be 3 minus 3 and 54 and 54. No, what is happening? 76, 3, 57. Okay, 57 and 17. So 3 and 17 by 19, and 103 by 21 is 4, 84, and then we have 19 by 21. Okay, so how many integers we have to find now? Okay, so this is nothing but negative of 3 plus 17 by 19, and this is nothing but 4 plus 19 by 21. Okay, so if you try to visualize the location of these two numbers on the number line, so we have this number line O is the origin, and 4 plus 19 by 21. 19 by 21 is a proper fraction. It is less than 1. So 4 plus 19 by 21 will be somewhere between 4 and 5. So let's say this is 4, and let's say this is 5. Integer 4 and 5. So over here, B, let's say the point B is representing the number. This number, let's say this is 4 and 19 by 21. The location of approximately the location of the rational number 4 and 19 by 21 will be somewhere between 4 and 5. Okay, and what about the negative of 3 plus 17 by 19? Now we have the negative numbers like minus 1, let's say minus 2, let's say this is minus 3, and let's say this is minus 4. Now definitely 3 plus 17, ignoring the sign, 3 plus 17 by 19 is a number greater than 3 and less than 4. So its negative will be somewhere here. This will be the point A. The point A is representing the rational number approximately negative of 3 plus 17 by 19. Now you see, we can approximately, I have approximately located the two given numbers. One is negative rational number and the one is positive rational number. So I can see that the negative rational number is some number lying between the two integers minus 3 and minus 4. And also the other rational number, positive rational number 4 and 19 by 21 is lying somewhere on the number line between the integers 4 and 5. So how many integers can we see between the point A and B? Those integers are, so the integers, so sometimes it is often useful if you can visualize the numbers on the number line. You need to approximately mark the point given values or rational numbers on the number line and do the analysis to solve the problem. So integers from this, whatever we have drawn on the number line, we can clearly say that integers lying, by integers it has asked the number of rational numbers with denominator as unity. In a rational number, if q, in a rational number of the form p by q, if q becomes unity, then it becomes p. And what is p? P is an integer. So any rational number with denominator is unity is nothing but an integer. Integers lying between, then we can say minus 74, 19 and 103 by 21 are will be definitely minus 3, minus 2, minus 1, 0, 1, 2, 3 and 4. It will not be 5. Between, it is saying between means all the integers will have to be greater than minus 74 by 19 and less than 103 by 21. So how many integers we have found? 1, 2, 3, 4, 5, 6, 7, 8. So 8. So 8 integers. 8 integers. So the answer is choice C. Answer is choice C. So the concept we applied is that we were given two rational numbers and they were in the form of mixed improper fraction. So we have to convert them to improper to mixed fraction to try to see where these two rational numbers lie on the number line. So once we have converted minus 74 by 19 into the mixed fraction negative of 3 plus 17 by 19, we can approximately say that this negative number minus negative of 3 plus 17 by 19 will lie on the number line between minus 4 and minus 3. Similarly, the given number 103 by 21, when we have converted it to mixed fraction, that is 4 plus 19 by 4 and 19 by 21, which is nothing but 4 plus 19 by 21, and we know that 19 by 21 is a proper fraction. We know that the value of 4 plus 19 by 21 will be greater than 4 but less than 5. So we can clearly look at that number, approximately look at that number, rational number on the number line, that is it will lie between 4 and 5. And then it is very clear that what are the possible integers lying between the two given rational numbers. Okay, let's solve problem number 5. Let me quickly check if all is visible or not. Okay, everything seems to be visible. Okay, problem number 5. If x1, x2, x3, dash 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 dot x10 are 10 rational numbers in ascending order, then which of the following lies between x1 and x10? The choices are, first choice is x1 plus x2 plus x3 up to plus x10 divided by 10. Choice B is x1 plus x2 plus up to x10, that is the sum of all the 10 rational numbers. Choice C is both A and B. Choice D is neither A nor B. So what is given? That x1, x2, x3 and x10 are 10 rational numbers in ascending order. That means increasing order. So which means that x1 is less than x2 is less than x3. Likewise, we have x9 is less than x10. So x1 is the least number and x10 is the largest number, and in between we have the numbers x2, x3 up to x9 in ascending order. Okay, we have this. Now it is asking which of the choices lies between the number x1 and x10. What is, so I mean, we have to now, for this kind of problem, we have to see the choices. What are the choices? I mean, so it is x1 plus x2 plus x3 plus x10 divided by 10. Will this lie between x1 and x10? Now we know that from the properties of rational number, what we know that if for if A less than B, if A less than B implies that the number A plus by 2, A plus B by 2 will lie between A and B. We know this as a property of rational numbers. If there are two rational numbers A and B where A is less than B, then we know that A plus B by 2 will lie between A and B. That is, A plus B by 2 will be greater than A and less than B. So how we can use this concept to solve this problem? Now, uh, can we use this uh, x1 x1 plus now clearly we see that since x2 x3 and up to x9 they are all lying between x1 and x10, so we can say that x1 is x2 is greater than x1 but less than x10. We can say this. Similarly, we can say that x for x3 also, that x3 is greater than x1 and less than x10, less than x10. Similarly, for x4 we can say that x4 will be greater than x1 and less than x10. So like this we will have x9 will also is lying between x1 and x10, so we can say x9 is greater than x1 and less than x10. Okay, so we are having this relation. If I call these relations or equation inequality, actually these are inequality as 1, 2, 3 up to we have, these are 9 inequalities because it's starting from 2, it's starting from 2, 3, 4, 5, 6, 7, 8, 9. So there are how many? So there are 2, 3, 4, 5, 6, 7, 8, 9. So there are 8. There are actually 8 equations. Anyway, so if I now add all these 8 inequalities, what do I get? If I now add all these 8 equalities, I will get that. So I will get x on the, see, since there are 8 equations, since there are 8 inequality, if I add all these inequalities, I will get 8 times x1. So 8x1 will be less than, in between I will have x2 plus x3 plus x4 like this up to plus x9 also will be less than 8 times x10, 8 times x10. Okay. So we are getting that we are having this 8 times x1 is less than we are getting x2 plus x3 plus x4 up to x9. This is lying between 8 times x1 and 8 times x10. Now please note that if you have something like a less than b, if you have for some rational numbers, for any numbers, let's say it could be rational number or integer or whole number, whatever, if you have a less than b, then I can always in this inequality add a on both sides and say that a plus a will be less than b plus a. Or if the inequality was opposite, let's say if you have c greater than d, if you have something like this, c greater than d, this will imply I can add c, I can add say basically the result is, if you have something like this, if you have something like this, a less than b, if you have a less than b, I can add any non-zero constant to both, any non-zero number on both sides. The same, if I can add same non-zero constant or number on both sides, and the inequality will remain the same. I can say a plus c less than b plus c. I can say this. Similarly, if you have something like, let's say c, if you have something like c greater than t, c greater than d, 9. C greater than D, I can add any non-zero. I can add any non-zero number on both sides. Same non-zero number on both sides. The inequality will remain the same. I can say C plus K greater than D plus K, where K is some non-zero number. Now, from this, we have this. I need to see whether the summation of x1 plus x2 plus x3 plus x4 up to x10 by 10 is lying between x1 and x10 or not. That is what I am trying to achieve. And see, check. So what I have got from this, I have got that 8x1 is less than x2 plus x3 plus x4 up to x9. I got this. Now, this will imply I can add x1 to both sides, and I will get 8x1 plus x1 will be less than x1 plus x2 plus x3, likewise up to plus x9. I will get this. This will be x2. So I got, this implies that 9 times x1 is less than x1 plus x2 plus x3 plus dot 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 plus up to x9. We got this. On the right hand side of the inequality, we still need x10. Then we can think of some. Then we can decide something. But because we need to see where does x1 plus x2 plus x3 up to x10 divided by 10 lies. Now, if I extend we know this. Okay. Now, if I extend, if I add extend to both sides, I can add anything, any non-zero number to both sides, and the inequality will remain same. This implies I can do, if I add extend to both sides, I get x1 plus x2 plus x3 up to x10. Okay. We got this, but I need to the left hand side. Now, if I divide by 10, it's 1, 10x1, it's 1. This one is less than we are having this. Okay. Now, if I divide, also notice that if you have something like any inequality less than or greater than this could be an equality. I am discussing with a less. If you have a less than b, this implies that a by k, or rather a multiplied by k will be less than b multiplied by k, where k is some positive constant, any number. It could be less than, it could be any positive constant, that is greater than 0. It could be less than 1, greater than 1, whatever. We have this. So now, from this, if I divide both sides, dividing both sides by 10, we get 9x1 plus x10 divided by 10 is less than, we got x1 plus x2 plus x3 plus up to x10 divided by 10. So we got this. We can see that x1 plus x2 plus x3 plus x10 up to x10 divided by 10 is greater than 9x1 plus x10 by 10. But we have to prove that, we have to check whether on the right hand side this is, we have to see whether this is greater than x1 or not. We have to see if this is greater than x1 or not. Now 9x1 plus x10 by 10. Is there any other, this is getting a bit complicated, is there any other way we can solve it? Because I think this concept on the right hand side, a plus b by 2 lies between a and b, we should apply, we should use this somehow. How can we use this? X1 is less than x2, so which of the numbers? X1, okay, between x1 and x10, x1 and x10. So basically for the choice, okay, choice B is definitely will not be the correct one, because choice B, let me first eliminate choice B. Choice B is saying that, we can clearly see it is saying that the number x1 plus x2 up to plus x10 is saying that it lies between x1 and x10, lies between x1 and x10. Now it is not given about whether the numbers are positive or negative, nothing is told about that. So this number x1 plus x2 plus up to x10, will this be less than x10? This is the question, because it is saying that which of the choices will lie between x1 and x10. That means it should be greater than x1 and less than x10. If this is so, then no, this cannot be true, because now it depends, we really do not know whether x1, about the nature of these 10 rational numbers, whether they are positive or negative. I mean, if this is true, if this is true, then it will imply that, this will imply, we can cancel x10 from both sides, it will imply that x1 plus x2 up to x9 is less than 0. So this whole thing, x1 up to x9, their summation is 0, which will mean that some of them will be positive and some of them will be negative. It can be, I mean, but no, I do not think this will be true, because x1 plus x2 plus x3 up to x9 plus x10 cannot be less than x10, cannot be less than x10. So I am assuming that all the rational numbers are positive, even though it is not given in the problem. I think if assuming that both all the rational numbers are positive, this cannot be true. So this cannot be true. So this is true. This cannot be true, because if you have, you cannot have A plus C less than C. A plus C less than C unless and until A is a negative number. A is a negative number. So anyway, so B is not possible. Now, if B is not possible, then definitely the choice C is that both A and B. No, choice A, C will not work. For choice C will not work because we have already seen that B is not a correct choice. Now, what about D? D will only be true. We can choose D only when A is false. The choice A is also false. So for that, we have to see what is choice A. It is really depending on the choice A now. By 10. Now, what can we do? Okay, we are at question number 5. For the time being, I will skip this problem. I will come to this problem later on. So let's try to solve the other problems. Okay, let's give some space. Problem number 6. If x and y are two rational numbers, then which of the following doesn't lie between x and y? If x and y are two rational numbers, then which of the following doesn't lie between x and y? If x and y are two rational numbers, then which of the following doesn't lie between x and y? Now, it is not given whether x is greater than y or x is less than y. It is just saying that which of the choices will not lie between x and y. So let's say, it does not matter. It does not matter whether x is less than y or x is greater than y. We will, if x is less than y, let's say, if either x will be less than y or x will be greater than y. So if x is less than y, this will imply we can always have that x plus y by 2 will be greater than x and less than y. And we will have, if x is greater than y, then we will have that x plus y by 2 will be greater than y and less than x. Now, in either case, irrespective of whether x is less than y or x is greater than y, we will always have, we can see that x plus y by 2 is lying between x and y. Now, whether x is greater than y or y is greater than x, it is not known. But anyway, whatever on the number line, whatever be the position of x and y, let's say this is x and let's say this is y. We don't know whether y is to the right of x. We don't know whether y is to the right of x or y is to the left of x. We don't know. It could be to the right, it could be to the left. The fact remains that x plus y by 2 will always be in midway between x and y. Either this is true, or for the case x less than y, and for the case x greater than y, on the number line it will look something like this. So y is smaller than x, and we will have somewhere in between x plus y by 2 is lying in between y and x. So we will have this. So in any case, x plus y by 2 will always lie between x and y, irrespective of the fact whether x is to the left of y or x is to the right of y on the number line. Now, what is it saying? Then which of the following doesn't lie between x and y? Doesn't lie. Choice A, 2 by x plus y. Now, okay. Let's which of the choices will not lie between x and y? Okay, if this is true, let's say if x is less than y, either x will be less than y or x will be greater than y. So we are considering both the choices. Let's say if x is less than y, this will imply that x plus y by 2 will lie between x and y. It will be, so x plus y by 2 will be greater than x and less than y. Now, one concept you must know, that if x is greater than y for two non-zero numbers, the rational numbers x and y. If x is greater than y, this will imply if you take the reciprocals, the inequality will change. That is, 1 by x will be now less than 1 by y. So this implies that lie between, which one does not lie between x and y. Mm. 5 by 4. One by x less than 1 by y. X plus y by 2. So we are having, if x is less than y, we are having that x plus y by 2 is greater than x. X plus y by 2 is greater than x. Then will x 2 by x plus y is reciprocal of x plus y by 2. Now the question is, for any two rational numbers, if a is greater than b, let's say a and b are non-zero rational numbers. If a greater than b, can we say will this imply that 1 by a will be less than b? Is it always the case? If a is greater than b for two non-zero rational numbers a and b, then if you take the reciprocal of a, will the reciprocal of a, can we say, will be less than b? Is it always true for any non-zero rational numbers a and b? 3, 4. If it is greater than 4, 1 by then which of the following doesn't lie between x and y? Doesn't lie between x and y. Now, if doesn't lie between x and y, now I will try to solve this problem in a reverse way, that I am trying to and kind of reverse engineering. I am trying to think, if let's say if let's say 2 by, the first choice 2 by x plus y is not lying, doesn't lie between x and y. So this will imply, A implies that 2 by x plus y is less than x. For the case if x less than y, for the given rational numbers x and y, let's say x is less than y, then definitely let's say if x is less than y, then the choice A is saying that if we assume it to be true, that is 2 by x plus y, it doesn't lie between x and y, then definitely it will be less than x. So 2 by x plus y is less than x, and let's see if we, from this, if we arrive to any contradiction or not. So this will imply I can now or any two rational numbers, then which of the following doesn't lie between x and y? Okay, so one thing just struck in my mind for this kind of problem. Possibly you can choose, since it is saying if x and y are two rational numbers, then and nothing is said about x and y, whether they are positive or negative. You can possibly choose some specific values of x and y and see what is working. So let's say if I, so trial and error, I am doing some trial and error. So I am taking x equals to 1, x equals to 1 and y equals to 2. So let's see, so what is 2 by x plus 1 is equal to 2 by 3. So definitely 2 by 3 is less than 1, is less than x. So it is not. So if I consider a specific value of x and y, x equals to y and y equals to 2, we can see that 2 by x plus 1 is coming out to be 2 by 3, which is a proper fraction, which means it will be less than 1, which means that it is less than x, which means that 2 by x plus y is not lying between x and y. If it lies between x and y, then it should be greater than x, and we are seeing that 2 by x plus y is coming to be less than x. So this was if we choose x is 1 and y is 2. What about if we choose x equals to 2 and y equals to 1? Then 2 by x plus y will be the same thing, 2 by 3, and which is also less than y. So in any way we can see that 2 by x plus y, whatever value we choose for x and y, you will see that 2 by x plus y is not actually lying between x and y. So this is a way of solving a problem. For this kind of problem, you assume any values of x and y. Since it is given that x and y are two rational numbers, no other specific information is given about x and y, that whether they are positive or negative. You can choose any random values, any some values, which it will be easier for you to do the calculation and see what choices is working or not. So we can clearly see that 2 by x plus y will not lie between x and y, irrespective of whatever value you choose for x and y. So this is a kind of not a straight away solving the problem, but kind of a reverse engineering, that is solving the problem backward using a trial and error method. So the correct choice, I think, is A. Now this choice D is all of this. Can we say that x plus y by 3 will also not lie between x and y? You should also check that. Now what is x plus y by, so I have considered two cases. So for this, what is x plus y by 3? This is 1 plus 2 by 3, that is 3 by 3 equals to 1, and 1 is definitely not lying between x and y. Between means between x and y means it will be greater than y, greater than x and less than y, but 1 is not greater than 1. So definitely 1 is not greater than x. So definitely 1, if x is 1 and y is 2, then x plus y by 3, which is coming to be 1, it is not lying between x and y, because it is becoming equal to x. X does not lie between x and y, or y does not lie between x and y. You should have a clear understanding of this. So definitely x plus y by 3 is also not lying between x and y. What about, this was regarding x equals to 1 and y equals to 2. What about if x equals to 2 and y equals to 1? Then also you will see that x plus y by 3, it will be the same, that is 1. So it is becoming equal to 1. In this case also it is not lying between x and 1. So x plus y by 3 is x plus y by 3, once again, which of the following doesn't lie between x and y? Between x and y. Doesn't lie between x and y. So we are having x plus y by 3 is also not lying between x and y. Okay, So what about x plus y by 10? I think x plus y by 10 will also not lie between x and y. Let's see what is x plus y by 10. This will be 3 by 10, and 3 by 10, where does 3 by 10 lie? 3 by 10 is definitely less than y, less than 1, that is 3 by 10 is definitely less than x. In the first case, we have assumed x is 1 and y equals to 2, and we see that x plus y by 10 is coming out to be 3 by 10, which is less than 1, so which is less than x. So it is not lying between x and y. And what if for the cases where we choose x equals to 2 and y equals to 1, so definitely x plus y by 10 will again will be equal to 3 by 10, and also this is coming to be less than y. So in any case, so x plus y by 10 is also coming out not to be lying between x and y. So the correct choice is not A, but the correct choice is D. So whenever you have choices like all of these or none of these, or both A and B, or neither A nor B, you should carefully check all the choices. So for this problem, the answer is D. Okay, let's do problem number 7. If y is the reciprocal of a non-zero rational number x, if y is the reciprocal of a non-zero rational number x, then the reciprocal of y is, what is saying? It is saying that y is the reciprocal of a non-zero rational number x. So reciprocal of a non-zero rational number x means x to the power minus 1, that is 1 by x. Then the reciprocal of y is reciprocal of y. Okay, so it is asking the reciprocal of y. The reciprocal of y is equal to y to the power minus 1, and y we know is that x to the power minus 1. So y to the power minus 1 will be x to the power minus 1 whole raised to the power minus 1, and we know from the laws of exponents that the two powers gets multiplied. So this will be x to the power minus 1 multiplied by minus 1. This is x to the power 1. This is equals to x. So the correct choice is A. The correct choice is A. Even though it's this problem was relatively easy, but it just checks your concept about reciprocals or multiplicative inverse. Okay, let's do problem number 8. The difference of two rational numbers x and y, where it is given x is less than y, is 6. So it is given the difference of two rational numbers x and y, where x is less than y. So it is given that y minus x equals to 6 is given. Their product is 27. Okay, so xy is given to be 27. Then the difference of their multiplicative inverses. So difference of their multiplicative inverses will be multiplicative inverse means reciprocals. Difference of their multiplicative inverses will be equal to now since you should realize that x greater than y will imply that 1 by x will be less than y. 1 by x will be less than 1 by y. You should know this concept. If x is greater than y, then we will have their product is given to be 27. Their product is given to be 27. Okay. So if x is greater than y, we will have 1 by x. The reciprocal of x will be less than. The inequality changes when you if you take the reciprocal for a given for a inequality x greater than y, if you consider the reciprocals, then the inequality will change. That is 1 by x will be less than 1 by y. So the difference of the multiplicative inverse will be oh sorry, it is given that x less than y, x less than y. So 1 by x will be greater than 1 by y. So we can say that the difference of the multiplicative inverse will be 1 by x minus 1 by y. It is asking the value of this. Now if you are given y minus x, the value of y minus x and xy. Now y minus 1 by x, the difference of the multiplicative inverses is 1 by x minus 1 by y. If you do simplify this, you can clearly see it will be y minus x divided by x and y. I hope you are familiar with this kind of simplification. This is based on algebraic expressions. So now it is clear, you know that y minus x is 6 and xy is 27. So this becomes x by 27. This is 2 by 9. This is 2 by 9. But why it is given half 3 by 2, minus 2 by 3 and 2 by 3? The product is 27. Okay. And the difference is 6. So it should be 6 by 27. That is 3 by 9. Okay, I think there might be some mistake in the choices given. 2 by 3, it should be 2 by 9. 2 by 9. So, in all the choices, instead of 3, it should be 9. I might have done some mistake in writing the problem. So, I think my solution is correct. So, y minus x, the difference of two rational numbers x and y, x is less than y. So y minus x is 6. The product is 27, that is xy is 27. And since x is less than y, we will have 1 by x greater than 1 by y. So the difference of the multiplicative inverses will be 1 by x minus 1 by y. And if you simplify this, taking the LCM of x and y, which is basically xy, you will have y minus x by xy. This is equal to 6 by 27. This is equal to 2 by 9. Okay, so 2 by 9 is the correct answer. But the choices given, and I think I have written it incorrectly. The choices, the answer is 2 by 9. Okay, let's do problem number 9. If x, y, z are three positive integers such that x by y, x, y, z are positive integers. So it is given x by y equals to 8 and it is given y by z is equal to 1 by 6 and it is given x plus z is equal to 42. Then the value of y is, we have to find y from these three equations. X by y is equal to 8, y by z is equal to 1 by 6 and x plus z is given to be 42. Okay. Now one way of solving this problem is that you can from x by y is given to be 8. You can get x in terms of y. From the first equation, I will get x and z in terms of y, and then I will put the values of x and z in terms of y in the third equation. So from this I will get x equals to 8y, and from the fact that y by z equals to 1 by 6, this will imply by doing cross product that z is equals to 6y. Now using this the values of x and z in terms of y, we can say using putting the values of x and z in terms of y in the third equation, we know that x plus z is given to be 42. This will imply if we substitute the x and z by their y values, we will get 8y plus 6y equals to 42. 2. This implies 14y is equal to 42. This implies y is equal to 42 by 14. This is equal to 3. So y equals to 3. So we have to find, then the value of y is given by. Okay, so y is 3. So 3 is the answer. Correct choice is choice A. Okay, let's do problem number 10, the last problem. Three rational numbers lying between minus 3 by 4 and half are. The choices are three. We have to choose which of the choices. In each choice there are three rational numbers. We have to choose the choice. So in each choice we are given three rational numbers. We have to choose which three rational numbers lies between minus 3 by 4 and half. Now you can see all the rational numbers, all the choices, the rational numbers are either an integer, that is 0, or they are having a denominator as 4 or 2, and also the two rational numbers, the range that is given between which we have to find the rational numbers, they are minus 3 by 4 and half. They are also having a rational number, the denominator as 4 and 2. So it is better if we can somehow, if we can convert all the rational numbers given with the same denominator, then we can easily compare the numerator and judge whether which rational numbers are lying between minus 3 by 4 and half. So this is already minus 3 by 4, let it be. The denominator is already 4, but the half, let's convert it to its equivalent rational number by multiplying by 2. I want to make the denominator 4, so it will be 2 by 4. Okay, now let's see. So what now let's see what are the choices. The choices A is minus half, 0 and 3 by 4. We can say this as the minus half, I can say as minus 2 by 4. I have converted minus half to its equivalent rational number so that the denominator is 4. This is 0 and this is 3 by 4. Now 0 by zeros, I can always write it as 0 by 4. Okay, now we have to see, now to see whether the choice A is correct or not, we have to just verify whether the numerators of choice A, that is minus 2, 0 and 3, lies between minus 3 and 2. So the numerators of the given range, that is the given two rational numbers between which we have to verify which other rational numbers are lying. The numerators are minus 3 and 2. This is 2 and this is 0. Okay, so we have to see for all the choices whether the numerators of all the three rational numbers are lying between minus 3 and 2 or not. So for the choice A, we have the numerators are minus 2, which is obviously lies between minus 3 and, so this will be somewhere minus 2, and this is minus 1, and this is 1. So minus 2 is lying between minus 3 and 2. Fine. 0 is lies obviously between minus 3 and 2, and 3 is not lying between minus 3 and 2. 3 is not lying between minus 3 and 2. So we can say this is the culprit of choice A. This does not lie between the given two rational numbers. The original rational numbers was minus 3 by 4 and half. We have converted it to have the same denominator 4. That is, we are now having minus 3 by 4 and 2 by 4. So we can clearly say that 3 by 4 is not lying between minus 3 by 4 and 2 by 4, because 3, the numerator 3 is greater than 2, So definitely the three rational numbers lying between. Okay, so A is correct, A is the wrong choice. A cannot be a choice. Now let's see what is B. For all the choices, the rational numbers for all the choices, we will convert them, all the three rational numbers, to have a denominator as 4. So B is already having all the denominator as 4. Now we have to check whether minus 1, 1 and 3 is lying between minus 3 and 2. So minus 1 is lying between minus 3 and 2, fine. 1 is lying between minus 3 and 2, fine. 3 is not lying between minus 3 and 2. So this is also not correct. Now we can also eliminate right away D, because in the numerator minus 5 by 4, the numerator is 5, minus 5, and minus 5 is less than minus 3. So this is also not correct. So clearly the correct choice will be, the only choice left is C. So this has to be the correct choice. Okay. Now let's see the questions which I was not able to answer. What was that? That was question number 5. Question number 5 I could not solve. Okay. Let's give another try. So definitely we have already eliminated choice B. Choice B will not lie between x1 and x10. So that means choice C is not correct. Choice B is not correct. Now choice D, neither A nor B. Neither A nor B. Now we have to, it really depends on the choice A. x1 plus x2 plus x3 up to x10 divided by 10, where it can lie. Where can it lie? Whether it lies between x1 and x10, we have to verify that. We have to verify that. Let's go to the place where I left. Okay, so this was the place where I left empty. Okay. What can we do? We know that x2 and x3 and x9, these are all lying between x1 and x10. We know that for x1, since x1 is less than x10, we will have x1 plus x10 divided by 2 will lie between x1 and x10. This we clearly know from the properties of rational number. Okay, what can we do? X2 by this is lying between x1 and x10. X1 plus x2 less than x1 plus x2 plus x3 plus x10 divided by 10. Okay, what do we have? So we have x10. So we got that 9x1 is less than x1 plus x2 plus x3 up to x9. Up to x9. From here, we got this. We got this. From this, can we say that? How can we say that? On the right hand side, we just need x10. As of now, we are getting 9x1 less than x1 plus x2 plus x3 plus up to x9. On the right hand side of the inequality, this inequality, we need x10 on the right hand side. X10. X1 is less than, yeah, x10. X1 is less than x10. Okay, so we have 9x1. We have 9x1. So far we got 9x1, x1 plus x2 plus x3 up to we got x9. We got this. Now, does this imply that, okay, yeah, I think I got it. So let's try to understand this thing. If you have a less than b for some numbers, if you have, it could be rational numbers, integers, whole numbers, whatever, it is given that a and b are some constant numbers. If a is less than b, then I can always say that a plus k1 is less than b let me write it clearly. Okay, so one concept I am trying to verify that if we know a less than b, if a is less than b, this will imply that if you a plus k1, where k1 and k2 are also some constant numbers, this will be less than b plus k2, where we know that k1 is less than k2. Please try to understand this. If we have a less than b in this inequality, if we add two constants on both the sides, that is, one is k to the left hand side, and to the right hand side if we add k2, where k1 is less than k2, then we will have a plus k1 less than b plus k2. Why so? Now, from here we can always get something like a plus c will be less than b plus c, where b is some non-zero constant. Now, don't you think that if so we are adding same constant c on both sides, we are getting a plus c less than b plus c. Now, don't you think that a plus c is already less than b plus c? If I replace c with another number k which is less than c, this will also imply that a plus k will be less than b plus c. Don't you think it will be? If I replace the c on the left hand side with k, where k is less than c, then obviously we will have a plus k less than b plus c. So from here, if I adding, from here I will not adding actually, this will imply that 9x1 plus, on the left hand side I am adding x1, and on the right hand side I am adding x10. So it becomes up to x10. From this inequality, where we have having 9x1 less than x1 plus x2 plus x3 plus up to x9. In this inequality, I am adding to the left hand side x1 and I am adding x10 to the right hand side, where I know that x1 is less than x10. x1 is less than x10. So definitely now we will have 9x1 plus x1 will be less than x1 plus x2 plus x3 plus up to x10. So this implies on the left hand side we are getting 10x1 less than, and on the right hand side we are getting x1 plus x2 plus dot 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 plus x10. Now if I divide both sides by 10, I will get x1 less than x1 plus x2 dot 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 up to x10, divided by 10. So we have proved one part, that x1 plus x2 plus up to x10 divided by 10 is at least greater than x1. Now we have to prove that x1 plus x2 plus x10 divided by 10 is less than x10. Is less than x10. Okay, how will we do that? So one part is proved. This at least shows that x1 plus x2 plus x3 up to x10 divided by 10, it is greater than x1. Okay, the way we arrived at 9x1 is less than x1 plus x2 plus x3 up to x9, the way we arrived, I will do it in the same way, but now I will consider. So we know that x10 is greater than x1. X10 is greater than x1. I can also say that x10 is greater than x2. I can also say that x10 is greater than x3. Similarly, I can say that x10 is greater than I can say that x10 is greater than similarly x9. I can say x9 up to x9. x10 is not greater than x10. So definitely I can say this x10 is greater than x1, x10 is greater than x2, x10 is greater than x3. Up to I can say that x10 is greater than x9. Now if I add all these 9 inequalities, what do I get? On the left hand side there will be 9 times x10 greater than, on the right hand side I will add up all x1 plus x2 plus x3 plus up to x9. The similar thing we are getting, but now the inequality has changed, and on the right hand side I am having x10. Now I will do the same thing, just like where we have a less than b. This will imply a plus k1 will also be less than b plus k2, where k1 is less than k2. Similarly, I can say that if a is greater than b, this will imply that a plus k1 will be greater than b plus k2, where k1 is greater than k2. If you think a little bit, you will understand why is this so. So now from this I will get that 9 times x10 plus x10 will be greater than x1 plus x2 plus x3 plus up to x9 plus x10. Now this time, even though I added both, I actually added the same thing, that I added x10 to both sides. I added x10 to the both sides. It is not, so it was the concept. So if you have, so basically what happened after this step, I added x10 to both sides. I can always add the same constant, same non-zero constant to both sides of an inequality, whether it's a less than inequality or greater than equality. I can always do that. So I just added x10 to both sides. So this implies that 10 times x10 is greater than x1 plus x2 plus dot 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 up to x10. So this implies x10 is greater than x1 plus x2 dot 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 up to x10 divided by 10. So this so x10 greater than x1 plus x2 plus up to x10 divided by 10 is nothing but, it also means that x1 plus x2 plus x3 up to x10 divided by 10 is less than x10. So it is proved that x1 plus x2 plus x3 up to x10 divided by 10 is lying between x1 and x10. So definitely the correct choice is answer A. A is the correct choice. So this brings to an end in solving the 10 good problems of set 1 on the chapter of rational numbers. So this solving these problems will really give you a good evaluation of your understanding of the concepts of rational numbers. So I will keep on making more sets of 10 problems on the chapter rational numbers, and I have also previously solved 10 good problems on the chapter of exponents. So I will keep on making, so 10 good problems will keep on coming for all the chapters that I will cover in the playlist CBSE Maths 8 following the textbook of R.S. Agarwal. As soon as I complete a chapter over there, I will add 10 good problems on that chapter in this playlist, that is Maths 8 Hot. I hope this video was beneficial to you. If it is so, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. See you soon in the next video. I don't know what set I will come up with. It could be so currently I am discussing the chapter squares and square roots in the playlist CBSE Maths 8. So once I complete that, maybe I will create a 10 good problem set number 1 for the chapter squares and square roots. So that will be the next 10 good problems from that chapter, and after that I will create more sets on the chapter of rational numbers and exponents. So that is all for this video. Thanks for watching, and until the next video, take care and bye.